The 3D printer is made up of several modules of equal length, which are equal to the distance between the building's columns. The modules consist of a slidable framework, an elevator for the cartridge cart, and rails for moving a manipulator. The modules are brought to the building site already fully assembled, which greatly simplifies and speeds up the installation, dismantling, and transportation of the printer. Once on site, the modules are assembled and mounted onto the building's foundation at the bottom of the excavation pit. It only takes up to a day from when the modules are delivered to start using the 3D printer. The elevator lifts a cart containing a cartridge filled with concrete and exchanges it with an empty cart, which it then lowers to exchange it for a cart with another batch of concrete. In this way, the printer can continuously pour the concrete. The formwork is lifted with the help of jacks located on the outside of the vertical structure. The rods are connected to each other as well as the walls of the structure and serve as interim reinforcements until the structure is complete and the cables are tightened. Vertical and horizontal dividers are inserted in between the columns and the slabs in order to separate them from each other when the plates are rotated. Coils of reinforcing cables, steel or concrete, are mounted on the frame formwork and unwind as the formwork is raised, releasing some of the cable into the slabs and columns as they are poured. Once the concrete solidifies, the cables are tightened. The carriage cart is equipped with concrete dispensers. When the cart is moved along the formwork, the dispensers release the concrete in accordance with the central program that controls the flow of concrete into the layer being formed. This limits the thickness of the concrete layer to not exceed 5 to 10 centimeters, which reduces the load on the formwork structure and, in turn, its weight and material consumption. The manipulator is fully automated and can take components from the cartridge cart and install them in the appropriate section of the concrete layer that is currently under construction. The manipulator has a set of rails that allow it to move in parallel to the concrete cartridge. The manipulator is equipped with a gripper, by means of which it can install various components into the concrete layer being poured, including cavity-forming plastic blocks, swivel hinges, reinforcements, and other embedded parts. The manipulator installs the pivotable swivel hinges in the middle layer of the plate that is currently under formation. The hinges are of a pipe-in-pipe type, allowing for one part of the hinge to be placed inside the column and the second part inside the floor plate. To reduce the weight of the plate and material consumption, the manipulator installs cavity-forming blocks side by side on the top surface of the concrete plate currently being formed. When the next layer of concrete is poured on top, these blocks create voids in the plate. Kits of armature, swivel joints, and other components to be embedded into the concrete are delivered via trucks to a warehouse at the construction site. Next, an automated warehouse management system batches the kits onto cartridge carts, which are then delivered to the desired printer for installation. An automated concrete management system delivers concrete from truck mixers or concrete mixing units located on site to the 3D printer via cartridge carts. Vertical printing technology, VPT, is able to build structures at a rate of 1 floor per day. Thanks to the VPT technology, constructing the mainframe of a 5-story building can be completed in only 5 days. After completion, the printer is dismantled and transported to the next construction site. In this way, you can minimize the downtime of the VPT printer, cutting down the costs of operating the printer. After the printer is dismantled and the concrete sets, it is tested for compressive stress. To do this, anchors are attached to the ends of the cables that span the concrete slabs. The cables are then tensioned with hydraulic jacks. In order to solidify the bond between the concrete, anchors, and cable, either cement paste or solution under pressure is injected into the channel. The injection is conducted through the tees inserted during the manufacturing process. Before rotating the floor plates from vertical to horizontal, the tensioning cables are cut at the horizontal divider between 2 plates. After this step, the jack supports are removed using winches and the plates are rotated. Once the floor plates are rotated into place, The gaps between the plates need to be filled with concrete. Formwork is installed to support this step. Additional cables are threaded through the existing channels in the columns and laid down in the formwork. Reinforcing cables are also installed in the transversal channels in the vicinity of the columns. Adjacent floor plates are joined and reinforced at their interface. After this, the structural joints are glued together. Once the concrete has strengthened, the reinforcement cables are tensioned. Once the frame of the building is completed, the next step is to fill in the building walls with the desired building material and install the door and the window frames. Vertical printing technology, VPT, allows you to build high-rises with any number of floors.